Okay, so my hope is to help guide a little bit of the discussion that will occur during this lab. And this discussion can happen anywhere you see a teachable moment. So it may be in the beginning when you're going over different pieces of equipment, or it may occur at the end where you have issued the students their muscle that they have to go through a process. I feel it does apply a little bit better with the second half because then they have to brainstorm some of these issues. However, if you do it that way, you might have to walk from group to group to kind of give them a hint on what they need to consider. That way, when they come back as the group, some of the students will know to mention some of these points. That way, there is kind of an inception of the reciprocal learning that can occur across peers. So that's the process I tend to take. Discuss it if it comes up at the beginning, but for the most part, I like to say, well, what about gravity? What are you thinking about gravity? How does the resistance on the band impact this, or how does the positioning of the joint impact what's happening with that resistance? So I'll go over some of the things that I just like kind of breezed over right there through this process. So now the students are coming in with a fairly sound knowledge of the length tension curve. We know that your greatest amount of tension development is going to happen somewhere just past the midpoint of the muscle's length. So if we're using flexion and extension, it's going to be just a little bit past or more towards the extended side of that muscle's length that they will have the greatest amount of force generation due to some of the actin-myosin overlap interactions. So, well, that's great, but patients-wise, oftentimes are going to have an area in the range of motion that might not fit with the traditional setup for resistance training for a muscle. So now we do know that if you work out that muscle, it's probably going to gain strength across the entire range of motion. However, it might not develop skill at recruitment of that muscle in the range that's needed for the functional activity. So if you're asking somebody functionally to do something that tends to keep their arms more extended and is still a bicep curl as a overarching theme for this discussion, you're probably not going to have them just do biceps curls. There's a good chance that it might be more beneficial to have that person do resistance training in the range of motion that's optimized for that portion that's relevant to the functional activity. So I'm not going to have them do way up here if really I need them to work on this last little bit, and I can target that more specifically with more resistance through elevating the arm and just working through that range of motion. So can we make the exercise prescription more specific to the ADL? Still can do the general strengthening, but can you do a little bit more specific targeting? The next aspect that you have are some teachable moments that will come up with the free weights and or bands. So we'll start off with the free weights for ease of understanding. Black indicates the stationary portion of the movement or the joint that's being talked about. So in this case, if we're sticking with the biceps example, we're going to look at this being the humerus and this being the forearm, and we'll use that same format. The black will represent the humerus side. So in this case, we're talking about free weights. The little blue circles indicate the free weights. So the primary force that creates resistance that your muscles are generating force against is gravity. And gravity, if we use standard lever arm mechanisms, gravity is going to have its maximum amount of force when the lever arm is longest. So in this case, we're at roughly 90 degrees of flexion of the elbow. That means this is going to be where we have the greatest amount of force generated by gravity because that's the largest distance. If we look up here, that's smaller than the overall lever arm length is smaller up here when we look at the force of gravity. If we look at it here to here, also smaller there and there. So it's important to keep in mind your length tension curve, but it's also important to keep in mind what the effect of the lever arm position is relative to gravity and relative to the axis of rotation. So in this case, if I want to have that peak of resistance in mid-range from that weight, then I'm good to be upright. However, if I take that person and I lie them down and I put that limb in 90 degrees, now my force is straight down towards the ground. I have, if anything, a compressive force into the joint, which isn't really activating the biceps or the triceps really outside of a stabilization process. But what changes also is we now move the weight from one side to the other side of the axis of rotation. In this case, now I'm using extensors to keep that weight from smashing this person in the head. Or if I stay on the distal side of the axis of rotation, now I'm creating a force that's going to engage the biceps to keep that from straightening out any further. So where you'll see this come into the biggest play in the lab is when they start to talk about working out external rotators with a weight in upright. Oftentimes they forget that once they get up to here, now you have a force that's really, if anything, just trying to bring the arm down. It's not looking at recruitment of the external rotators anymore. So that's kind of a key discussion point that I have for the students here. For the resistance bands, if we look at the resistance bands create a little bit of a dynamic. So gravity and the effects of gravity are minimized and sometimes eliminated depending on how you have the resistance band set up. So everything is really coming from the resistance band here. Now, if we take this example, where this is anchored is very similar to the pull that you would get with gravity, right? So in this case, that lever arm is still the longest distance. So your primary lever arm point for resistance is in the same position. However, because this is a resistance band, as I move further away, this is going to increase tension on the resistance. So there's a good chance that this overall is going to have a greater amount of force that the muscle has to match or overcome than you will have at this 90-degree angle. So your lever arm becomes a little bit less important here. Now, we are also still victimized to that force. So if I get to the point where here, now my lever arm is in line with that band, instead of having a force that's trying to trigger biceps contraction, I'm really just getting a distractionary force on the joint. It doesn't really have to do much to maintain that position. The reason why is if I go this way, that's going to increase tension on the band, so I have to work to get it straighter. If I go this way, I have to work to bend more. So right there, it's kind of this pure distractionary force. Now, some of the principles that I mentioned on the free weight side of things happen here as well. So in this case, we've got the person in, say, a supine position, and we've got the band attached to the ground. If we look here, the band is in that maximum length from a lever arm standpoint. So distance from axis of rotation is here. However, I bend more, I have more resistance. So there's a good chance that I'll have more resistance on the muscle or that the muscle has to meet or overcome in this position as opposed to purely out straight. As I move towards this motion, if I have this a little bit more in line, this would become the same thing, a compressionary force on the joint. So it's not going to do too awful much for our flexors or our extensors if really it's more work for us to bend or to straighten. Once we move past or we flip the side of the axis of rotation that band is on, now you have more of a force to flex, so you have to use your triceps in order to keep that from bending further. Now, if we take this whole thing out of there and we move this over to resistance cables, very similar process as far as your anchor is concerned. However, now the resistance being provided through the cable is the same. You don't have an increase in elasticity on the band. because now you're using a cable. So in that case, this lever arm is now going to be maximized. So this goes back to probably being the most amount of resistance that that cable machine can create, because this is your maximum length of the lever arm based off of where that cable is anchored down at. As I bend more, I start to decrease that lever length, or distance from, not lever length, sorry, the distance from the axis of rotation. So this, and therefore it becomes easier as you get towards the end as far as the resistance that this is creating. Now, going back into the interplay, we obviously, for those of you guys who really study this stuff up, we're not talking a lot about the relationship of all of these positions to our length tension curve. So while I might have more resistance that's being provided by a band as I get further towards a flex position when it is anchored to the ground, I do have a drop off in some of the tension that can be created in the muscle, because now I have overlap or decreased areas for connection between the myosin and actin with my with the heads and the anchor points that you have within that muscle myofibril. So this, I think we start going down this route, we end up having a lot of confusion across the students. So I would just leave that component out, other than to say, like, just remember that you might be able to generate more force in this range of motion based off of your resistance band, or based off of your positioning relative to gravity, or your anchor point for the cable. But remember that there is an aspect of the length tension curve that you might want to keep in mind if you are doing a dynamic exercise. So specifically your isotonics versus your isokinetics. So, all right, I know that was a long video. I know it was maybe a little bit cognitively heavy, but these are the points that I do tend to go through with the students. And I try to like take one group and emphasize one aspect. That way they can reciprocally educate each other when we come back to the group meeting as one, and they kind of show the others how they approach the process of doing an active range of motion assessment for the muscle, doing a free weight prescription for the muscle, doing a resistance band prescription for the muscle, and then a functional activity. So let me know if you have any questions.